Let's look at the subject matter, annuities. Annuities. When we talk about annuity, though we have been able to look at a number of concepts or issues that are related to annuity in the preceding lectures, and as a matter of fact, we have considered the future values of certain amounts which are being invested for specific periods. And as a matter of fact, the concept of annuity actually makes it possible for annual payment to be made or received with respect to a given object, which is, undertaken for a particular period of time, usually at a regular period of time. So, however, most people do not save money in exactly that fashion. The following example, which we have actually considered before, has been able to tell us more about the subject matter of annuity. So by annuity, we simply refer to annual payment. That is, the payments that are being made or received, on annual basis. And as a matter of fact, the subject matter of annuity, the way we have actually seen it, we have observed that equal payments are made at irregular intervals of time, and as a matter of fact, a series of payments being made or received at a given point in time or at irregular intervals are usually regarded as what we call annuity. So as a matter of fact, the payment period in annuity may be a length of time, and in many cases it is usually undertaken for a specific period of time, usually at regular intervals. So the main characteristic of the subject matter of annuity is that the payments are made or received at a regular interval or a given length of time. Let's look at forms of annuity. Forms of annuity. We have different forms of annuity, or in a simple sentence, annuity can be in the following forms. Namely, we have what we call ordinary annuity. That's one of the forms of annuity. And by ordinary annuity, we simply refer to equal payments or payments that are made or received at irregular intervals of time. And as a matter of fact, a series of payments which are being made or received at irregular time intervals is usually called ordinary annuity. And in other words, like we have defined annuity, it is a sequence of equal payments which is being made or received at irregular time intervals. Therefore, ordinary annuity is a form of annuity whereby payments are made or received at irregular intervals of time. And the way we have defined it, this form of annuity is said to be a sequence of equal payments which are being made or received at irregular time intervals. So as a matter of fact, any form of annuity which is basically concerned with a sequence of equal payments either made or received at irregular time intervals is usually called ordinary annuity. Apart from ordinary annuity, we also have other forms like annuity due. When we talk about annuity due, this is another form of annuity, and by definition, this can simply be regarded as an annuity where payment is done at the beginning of payment intervals. So when we talk about payment being made at the beginning of a payment interval, we simply call it annuity due. Don't forget the way we have defined our annuity. We said annuity can simply be defined as a process whereby equal payments are made for regular time intervals. So we have two major periods concerned in this particular payment. We have the payment being made at the beginning and the payment being made at the end. So the payment that is actually made at the beginning of payment intervals is usually called annuity due. In a simple sentence, annuity due is a form of annuity where payment is done, made or received at the beginning of a given payment intervals. The major characteristic of annuity due is the fact that the payment is actually made or received at the beginning of the payment intervals. So we have perpetual annuity, that is another form of annuity. We have what we call perpetual annuity. And by perpetual annuity, we simply refer to a form of annuity which is majorly carried out indefinitely, especially when an annuity is greatly dependent on some event which cannot be fixed in nature, or in many instances we can simply call it contingent annuity. When we talk about perpetual annuity is simply viewed or regarded as that form of annuity which is usually carried out indefinitely, especially when an annuity depends on some events and these events are said to be unfixed in nature, that is, they cannot be fixed. So as a matter of fact, all form of payment which is being made or received and carried out indefinitely when an annuity depends on some event which cannot be fixed, it is called a contingent or perpetual annuity. So another name for perpetual annuity is what we call contingent annuity. It simply refers to that form of annuity which is carried out indefinitely when an annuity depends on some event which cannot be fixed. So as a matter of fact, we can also call it a contingent annuity. So let's look at some of the major notes or some of important notes on annuity. There are certain important issues that we have to take note when it comes to annuity. In annuity, each payment in annuity which is represented by R sometimes is called rent, and it is usually made at the end of time interval which is termed payment period, which means anytime we are calculating or solving problems that are related to annuity, we always refer to R and it's usually called rent. This rent that we have actually denoted by R is usually made at the end of a given time interval, and this time interval can also be called payment period, which means we have to take note of R, which is otherwise known as what? Rent. And this rent, we have said, is usually made or received at the end of time interval, otherwise known as payment period. Then 2, the interest period of the compound interest rate actually coincides with the payment of annuity. The second note we have to take note as important here is that the period of interest of the compound interest rate usually coincides with the payment of annuity, which means the payment of annuity is usually coincident with the interest period of the compound interest rate, and this is usually denoted by what? I, and is usually given what? In percentage. So also the accumulated or future value noted by F of an annuity is said to be the total amount that will be accumulated at the end of the annuity, especially if each payment is invested at a given rate of compound interest at the time of payment. So all these are very, very important, and as a matter of fact, they go a long way in calculating values for various annuities. So we have known our future values to be represented by F, our rent is represented by R, then the interest period or interest rate is usually measured in percentage and represented by I. So all these are the major important notes that we must take into account when we are solving problems that are related to annuity. So let's look at derivation of annuity. Like for example, if we have a particular problem that is related to annuity, so as a matter of fact, we have to apply the appropriate formula in order to solve that particular problem. So as a matter of fact, we want to look at how to derive appropriate formula for future value of an annuity. Derivation of future value of an annuity. So how do we derive appropriate formula for finding or computing the future value of a given annuity? In doing this, we have to take note of the regular payment which is being made or received at the end of the payment period, and where the compound interest rate is actually given as I per period. We need to be able to make use of that information for the purpose of computing the future value of annuity. So when the first payment is made, we represent it by R. That's first payment. And this first payment made, that is the rent, will actually earn interest over n-1 period. The period it will make, we said this is initial payment, and this particular initial payment will equally earn interest amounting to n-1 period. So, and this will amount to what? R into 1 plus I raised to power n-1. So it could be in naira or what have you. And the R in naira that we have paid at the end of the second payment will equally earn interest. This is for first payment. So the R we are going to pay for second payment, that will give us n-2 periods. That is for second payment. So as a matter of fact, we have our R into 1 plus I raised to power n-2. Then if we also get, the third payment, this payment will equally earn us, n-3 periods, which is our third payment. So as a matter of fact, we can still have our formula as R into bracket 1 plus I raised to power n-3. And this continues, proportionately or according to the number of periods we are asked to compute, and so on. So as a matter of fact, it should be noted that the last payment of R naira will not earn interest. Hence, the future value of annuity, which is usually represented by R, can be given as so we have the future value. We have R into brackets 1 plus I raised to power n-1 plus R into brackets 1 plus I raised to power n-2 plus R into brackets 1 plus I raised to power n-3 plus it continues, then plus R into brackets 1 plus I, then plus R. So our F future value give us R into R plus R into brackets 1 plus I plus R into 1 plus I raised to power 2 plus R into 1 plus I raised to power n-3 plus R into bracket 1 plus I raised to power n-2 is reducing, plus R into bracket 1 plus I raised to power n-1. So this can give us what? We can make use of what? The sum of GP to calculate this, because of the fact that if we are using sum of the first n terms of a GP with first term as R and common ratio as 1 plus I greater than 1. So as a matter of fact, if this is further worked upon, we can have our future value as R into bracket 1 plus I raised to power n minus 1 all over 1 plus I to bracket minus 1. This will give us is equals to R into big bracket 1 plus I raised to power n minus 1 over I. Because this one, the one we have here, will have cancelled this. So we have the future value as R into 1 plus I raised to power n minus 1 all over I. That is the formula for what? Calculating the future value of an annuity. Therefore, the formula for calculating the future value of an annuity is we have F is equals to R into big bracket. We have 1 plus I raised to power n minus 1 all over I, all in an enclosed bracket. So this formula is sufficient for calculating the future value of an annuity. So let's look at sample problems in relation to annuity. We have this question. A man deposits 8,000 naira at the end of every month into an account. A man deposits the sum of 8,000 naira at the end of every month into an account that pays or earns 12% per annum, and this is being compounded monthly. The question is, what will be his balance at the end of 5 years, assuming no withdrawal was made for the or from the account, as the case may be. The question we have here is like a man, is that of a man who actually deposited the sum of 8,000 naira at the end of every month, and that is made into an account that pays 12% per annum, and this is being compounded monthly. So we are required to calculate the total amount of money that he will have deposited at the end of 5 years, provided no withdrawal was made from the account. If you look at this question critically, we will see that it is a problem of annuity, and it is concerned with generating the future value of a given annuity. So to do this, we have to get all our parameters written out so as to know which one of these we are looking for. So the rent in this case here, that's our R, and it's equals to how much is deposited, which is 8,000 naira. So apart from that, we have the normal rate. Normal rate is given as 12%, and that's 12 over 100, which is 0.12. So as a matter of fact, number of compounding period, don't forget it is monthly. That means it will be compounded 12 times in a year. That is 12 months in a year. That's every month. That's 12. The number of years equals to 5 according to the question. So as a matter of fact, the nominal periods, we can get our nominal periods, and to get our nominal periods, that will give us the number of times, it is being compounded times the number of years. So that will give us n times 5, which is 12 times 5, and that will give us what, 60, which means we have 60 nominal periods. So the rate per period now, we have to get the rate per period since it will be compounded monthly. That will give us 12% all over 12, and that is 0.12 all over 12. That will give us 0.01, which means the rate per period will be equals to 1%, which is 0.01. So having gotten all the necessary and appropriate parameters, the next thing is just to go ahead and quote the formula. So by formula, or before then, don't forget the future value is not given to us. The future value represented by phi is actually unknown. That's what we are looking for. So this formula will be computed with respect to future value. So we have future value, which is f is equals to r into big bracket. We have 1 plus I raised to power n minus 1 all over I. So we have future value is equals to, our r is 8,000 into, we have 1 plus, our I, don't forget, is said to be what? 0.01. That is rate per period. 0.01. All raised to power n. Our n is 60. 60 minus 1 all over I, which is 0.01. The bracket is closed. We have 8,000 into, we have 1.01 raised to power 60 minus 1 all over 0.01. So we have 8,000 into, if this is further work upon, that will give us 1.816697 minus 1 all over 0.01. So we have 8,000 into 0.816697 over 0.01. So we have 8,000 into, when this is divided, we have 0.816697 divided by 0.01. That gives us 81.6697. So then times 8,000 naira. That gives us 653,357.6. So that is 653,357 naira 60 kobo. So with this shows that at the end of 5 years, the total sum of 653,357 naira 60 kobo will be in the account that is earning 12% per annum and compounded monthly. So as a matter of fact, that is the future value of the sum that is actually invested, with a total interest of 12% compounded monthly. Let's look at another question. We are still concerned with future values of annuity. This question says, it is a common knowledge that politics is a very expensive venture. Mr. Jide, a politician, hopes to join the chairmanship race by the year 2023. If he deposits 15,000 naira every 3 months in a savings account, paying 15% per annum, compounded quarterly, how much will he have in the account in January 2023 if the first deposit was actually made on 1st January 2009. If you also look at this particular question, it's a question that borders on future value of an annuity. In this case, we have it that Mr. Jide Babawale, who is a politician, actually hopes to join the chairmanship race by the year 2023. But if he begins to deposit 15,000 naira every 3 months in a savings account, which is actually paying 15% per annum, and it is being compounded quarterly, so how much will he have deposited in the same account by January 2023, provided if the first deposit was actually made on the 4th day of January 2009. So like I told us, this is the problem of what? Annuity, and especially it has to do with future value of an annuity. So to solve this, we have to spell out all the parameters given so as to know which of these variables or parameters is not given. So to do this, let's go by solution. Don't forget the deposit period. Deposit periods, we were told it is being compounded quarterly. So as a matter of fact, it then means that the deposit period will be what? 3 months. Every 3 months. So that is deposit period. And the interest rate is given as 15%, which is 15 over 100, and that is 0.15. That's our interest rate. So having gotten our interest rate, let's get our deposit period. Deposit period, do not forget we were told it is being compounded quarterly. So as a matter of fact, the deposit period will give us the interest rate divided by the number of times it is being compounded. We have the interest rate as 15% over 4, and that will give us 0.15 over 4. So this will give us 0.0375. That is deposit period. So the last deposit will be made. Don't forget, the last deposit will be made according to what we are told. The last deposit will be made in January 2023. Hence, n is equals to what? 17. If we calculate it from this 2009 to 2023, we have a total number of 17 years, which means the number of deposits is what? 17. So we have number of deposits, that is what? 17. So the amount in the account can be calculated using the formula for future value of an annuity. So by formula, we have the future value F, which is equals to R into big bracket. We have 1 plus I raised to power n minus 1 all over I. That's formula for calculating the future value. So we have our R, our rent. Don't forget our rent, which is R, is equals to 15,000. So we have to take note of that. So we have 15,000 into big bracket. We have 1 plus. Don't forget our I, that is the deposit period, that is 0.0375. We have 0.0375 all raised to power n. Our n, we got our n to be what? To be 17. That is the number of deposits from 2009 to 2023 minus 1 all over 0.0375. So we have 15,000 into big bracket 1.0375 0.03075 raised to power 17 minus 1 all over 0.0375. So this can give us 15,000 into, if we find 1.0375 raised to power 17, that will give us 1.0375 raised to power 17. That is 1.8698 minus 1 all over 0.0375. So we have 15,000 into this minus z, that will give us 0.8698 all over 0.0375. So we have 15,000 into, we have 0.8698 divided by 0.0375. That gives us 23.195. So that gives us 15,000 times 23.195. So we have 15,000 times 23.195. So future value will give us 15,000 times 23.195. That's 347,925. So which means by year 2023, a total sum of 347,925 naira will have been, made or deposited in the account. So based on the value we got, this actually shows that in January 2023, Mr. Babajide will have a total sum of 347,925 naira in his account. And as a matter of fact, it should be noted that the last deposit is on 1st day of January 2023. And as a matter of fact, this will not yield any form of interest. So based on that particular question, the future value is equals to 347,925 naira.